Hey y'all, let's talk constellations and seasonal stars and how long things move through the sky. I have set this for July, and I want to talk about this constellation here called Ophiuchus. Ophiuchus, by the way, is sometimes known as the 13th sign of the zodiac. You'll notice part of it kind of creeps down here really close to Scorpius. The signs of the zodiac, Capricorn, Sagittarius, Scorpius, Libra, Virgo, those are all the places where the sun can be found throughout the year. So that's the ecliptic. The ecliptic cuts through those 12 constellations. They're called the Zodiacal Constellations, which is a Greek phrase which means ring of the animals. Well, Ophiuchus actually kind of creeps down far enough, and the Earth's position relative, so the precession of the axis of the Earth causes the sun to move around, not just annually and monthly going through these different constellations, but how high or low it is in these constellations. And it turns out that Ophiuchus is actually in the path that the sun takes. So technically, Ophiuchus is one of the signs of the zodiac. So July, and Ophiuchus is pretty high up in the sky. I'm looking due south. There's the zenith. There's my southern horizon, so you can see some stuff that's coming up in the east. So what I want to do is skip ahead 1 hour. So look, 1 hour. So if you take 360 and divide by 24, that's 15 degrees. So every hour, constellations or any object is going to move about 15 degrees in the sky. Okay, so that was me going hour at a time. So now what I want to do, here Ophiuchus is at 9:30 p.m. Uh, in July, and what I'm going to do is advance to October, 9:30 p.m. Now you can see that Ophiuchus is actually setting on the horizon. So if you wait from one season to the next, so from summer into the fall, anything that's high in the sky in the fall during the winter, it's going to be low in the sky. Anything that's high in the sky in the summer during the fall, it's going to be low in the sky. So this seasonal stars thing is because of something called the sidereal day. So I'll get to that in a moment, but I wanted to make sure to discuss the fact that the constellations that we see in the sky change throughout the year, and you need to know that in a given season, something may be high up now, but one season later, it'll be setting low in the western sky. So let's discuss sidereal versus solar day. First things first, I've set this for solar noon for my local area, and you can see I've turned the meridian on, which is the line that cuts the sky in half. If I click on this thing and I go back a little bit, you can see it's anti-meridian, the sun is anti-meridian, it's on the meridian, so that's solar noon. It's on the other side, it's post-meridian, so that's PM. Again, AM on that side, PM on that side. Okay, so let me get exactly right at solar noon again. And I want to show you something. Now the sun is crossing the line exactly right. Let's actually stop time. And I'm going to click this thing that lets me pick the rate at which time passes. I'm going to pick something called a sidereal day. And then I'm going to turn off the atmosphere so that we can actually see what the sun prevents us from seeing the stars in the background. And I'm going to go forward one sidereal day and another, and we're going to go back. Notice that as I do this, the stars themselves aren't moving. A sidereal day is literally the idea, how long does it take for a star being at one position, the Earth to rotate on its axis, and that star to be at that exact same position. So that's 360 degrees. It's exactly 360 degrees. Okay? But if we, and here we're back at solar noon, let's go forward one sidereal day, and I want you to notice what happens to the sun. So in order for the sun to be back at solar noon, which we know takes exactly 24 hours, I now have to wait another 4 minutes. Okay, the sidereal day is 360 degrees rotation. A solar day is 360 plus a tiny little bit. So a solar day is 24 hours. Like, we make sense. We know that it takes 24 hours for the sun to be at noon, and then for it to be crossing the meridian and be at noon again. So that's not tricky. We understand that. The sidereal day, though, let's go forward one more. So I went 23 hours and 56 minutes in the future. So now I have to go over here and manually move this thing 4 minutes. Oops, one more. So every time I advance one sidereal day, the sky has rotated 360 degrees from me. The Earth spun exactly 360 degrees. But the Earth is not just spinning on its axis, it's also moving in its orbit. So that seems to make the sun move in the sky just a tiny little bit every single day. This is what causes seasonal stars. I earlier mentioned that Ophiuchus was high in the sky in the summer, and then in the winter, no, in the fall, at the same time of night, it was actually low in the sky. This is why the constellations change throughout the year, this weird sidereal day. The solar day is 24 hours. It takes 24 hours from noon to noon. That makes good sense. The sidereal day is 23 hours and 56 minutes. So we have to rotate a little tiny bit more than 360 degrees, okay? So I'm gonna do it one more time so we can, now that we're there, so this is solar noon, and then I'm going to advance one sidereal day. Oh no, we're not quite there yet. So I have to click on the minutes and go 1, 2, 3, 4. So it's 4 more minutes to go from sidereal day to solar noon. So a sidereal day is 23 hours and 56 minutes, and a solar day is 24 hours, which we already know. By the way, the word sidereal means relative to the stars. I think it's Greek for the distant stars. So if we could turn off the atmosphere, that would be bad. But if we could, you'd notice that it takes uh, 23 hours and 56 minutes for a star to be in one place in the sky and to be all set in the west and come back up and rotate again to that exact same spot. That's 23 hours and 56 minutes, which is about 4 minutes shy of a full day. So you setting your time to solar noon and then advancing one sidereal day, you're off by 4 minutes before the beginning of the next day. Okay, I hope that makes sense. And that goes in context with the seasonal stars. And if you can, you don't want to turn off the atmosphere. That's bad.